So, here's the question. Will Joe hit a home run? And the answer to that question is yes or no? 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 All right. Well, let's figure this out. So, we need two parametric equations for this one. The first one is we need the ball's parametric equation. Okay? So I get for that one, x is equal to 75 times the cosine of 28 degrees times t. Yes? The y I get is negative 16t squared plus 75 times the sine of 28 degrees times t plus 3.5. Yes? Okay. So let's put that on there. I'm going to go over here to the... Oops. I'm going to go over here to the computer and put it on because it's easier to put on. Yeah. So we had 75 times the cosine of 28 degrees times t, and we had negative 16 t squared plus 75 times the sine of 28 degrees times t plus 3.5. Yes? What's my t? We forgot one thing over here. We forgot what our t was equal to. What values of t are we going to go with? 0 to 0 to 3. Okay. All right. So 0 to 3 on those. Got to adjust my window now, right? Okay. So if I go into my window, how far out do I need to go? Need to get at least 190 feet, right? So I'm going to go 210 feet. By tens. How high? 50, maybe? 25? Doesn't get very high? Okay. 40. Let's go by tens. Okay. Yes? All right. So that's the ball. Yes? Okay. Now what do I have to do? Now I got to build the wall, right? Okay. So my wall my x is going to be what? 190, because that's how far out the wall has to be, 190 feet. My y, what's my y going to be? T? Okay. If y is t, what are my t values going to run between?
0 and 4.
0 and 4. Give me another example of a function that I could use there for y and differentiate my t's then. We have it.
It could be be 4t and then 0 to 1.
4t and we go t's from 0 to 1. It could be t squared and we go from 0 to 2. It could be t plus 5 and we go from negative 5 to 9. Right? No. Negative 5 to negative 1. Yeah. Okay? Alright? So now we got to build that wall. So we said 190, we said t, and we said from 0 to 4. Did Joe hit his home run? Nope, came up short, right? Okay. So he did not hit a home run. Okay. Follow-up question to that one is this. What or how much harder will he need to hit the ball to actually get a home run? Okay? Find me that value. Find me the value that the speed at which he's got to hit that ball to get a home run. 86 or 87? Okay? So what number am I changing on here? I'm changing that 75, that speed, right? Okay? So if I go, tab, if I go up here, and I change it to 85. Got to change them both. If I change it to 85, did he hit a home run yet? Not yet. Okay? So now let's go to, oops, I got to go this way. Easier. Escape. 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 There we go. So now let's go to 86. Ooh. Now, if we could just zoom in, zoom in. Oh, come on now. I thought I could do a double zoom. Apparently not. Oh! Fat fingers. Come on now. There we go. Did he hit a home run? Yeah. Yep. So 86 gets me that one. 85 didn't, but 86 does. Oh, well, let's use my finger. We're going in feet per second. Okay. Fantastic. I like this one. How far can Lucas Linsmeyer throw a ball if he throws it at an angle of 58 degrees with an initial velocity of 36 feet per second at an initial height of 4 feet? Okay? Boom. Find me how far he can throw that ball. What are my x and y equations? X equation for this scenario. Go ahead, Matt.
36 cosine of 8.
Okay, and y? Negative 16t squared, right? Plus, anybody? 36 sine of 58 degrees times t plus 4. T values 0 to 0 to, you put 4? Okay. As long as it goes past the x-axis, right? Right? Okay. As long as it goes past the x-axis and doesn't stop short. Because that'd be pretty impressive if you could throw a ball and just have it hover right there and just stay right there. You know what I mean? Okay? Alright? So we got that. So, when you graph it, you get this. Right? What do we need off of that? We need the x-intercept. We need this point right there. Right? How am I going to find that point? Change the question. What does that purple point represent? Or, what's going on at that purple point? It's when the what hits the ground? It's when the ball hits the ground. Okay? So Lucas throws the ball, and that's the point where it hits the ground, right? Hey, what else do I know about that point? We got Kevin?
It's below 40.
What do you mean it's below 4? Okay. But I want to know exact stuff. You know what I mean? Yeah. I want to know exacts. Okay. What else do I know about that point? It is below 40. It's between 30 and 40, right? Okay. It's what? Okay. What else do I know about that point? The height of my ball is 0, right? So y is 0. That's kind of key. Because now what I have to do is I have to set my y value. Let me move this back down here. Oh, tap the brakes. Let me move this back down even some more. Okay. I have to set my y value here to be 0. So negative 16 t squared plus 36 times the sine of 58 degrees t plus 4. I set that equal to 0. Because that's where my height is 0, right? Why would I do that? And t is going to give me what? The time that it takes for the ball to hit the ground, right? And then I can take that, put it back into my x equation to get the horizontal distance, correct? Okay? So, how am I going to go about solving negative 16t squared plus 36 sine 58 degrees t plus 4? How can I solve that for t? What? Quadratic formula. And so then that's going to give me like a's and b's and c's, right? Let me show you a shortcut. Okay? What is my a value? Negative 16. What is my b value? 36 times the sine of 58 degrees, right? What is my c value? 4. Now I could type those in, right, every time, or what I can do on my graphing calculator is I can store them as their variables. So negative 16, I'm going to store as A. 36 times the sine of 58 degrees, I'm going to store as B. 4, I'm going to store as C. Now, why would I do something so crazy like that? Well, I would do that because now I can type in the opposite of B. Oops, tap the brakes, maybe I can't. Whoa, now I got multiple fractions going on. Come on here, Lindmeyer. I would go the opposite. Why is it giving me this? Come on now. The opposite of B plus the square root of B squared minus 4 times A times C. All over 2 times A. My quadratic formula, right? And when I get that, I get that. Is that the one that I'm looking for? No, that's if we went back in time, so instead of him throwing it from 4 feet, that's if he would have thrown it from the ground under the same conditions. Okay, so we have to go back up into here, and we have to change, and we have to go to the other one. Instead of plus, now we go minus. And there are my 2 zeros. My 2 values of t that will give me a height of 0. So that would be t equals negative 0.123 seconds, or t equals, what was it, 2.0319119. 2.0311, that's a bad 3. 119. Yes? Okay. So now I've got to put that t value back into my x equals 36 times the cosine of 58 degrees times 2.03119. And that's going to give me how far Lucas threw that ball. Times 36 times, times the cosine of 58 degrees. So he threw the ball 38.75 feet, which, Kevin, does that work with what our guesstimate was? Something below 40, something in between 30 and 40, yep. Okay, so he threw the ball 38.75 feet. Okay. Follow-up question. How high did he throw the ball? Now what are we looking for? Follow-up question. What is the maximum height of the ball thrown by young Lucas? What point am I looking for now on my graph? What do we call that? Call that the vertex, right? So I'm looking for this point up here, the vertex. How am I going to find the vertex? One of two ways. Because we have A and B stored in our calculator already, right? So we could do opposite of B over 2A. Or the other way is I could average these two numbers. Because those are my x-intercepts. I could average those two, and that would give me my t value for that. Okay? So that's going to give me opposite of B divided by 2A. That's going to, whoa, that's wrong. That should have been, oh, I forgot to put it in parentheses. We'll go like this then. The opposite of B, oh. Escape. Opposite, what the heck is going on today with the calculator? Opposite B over 2A gets me 0.954, yes? Okay. So that's the t value to get to the vertex, correct? So I can store that now as my t, because now I want to put that into negative 16 t squared plus 36 times the sine of 58 degrees times t plus 4. And that's going to give me the maximum height, right? Because y is height. And I get, so at most it was 18.56 feet in the air. What did I say? 0.56? Looking back on our chart, or on our graph, does that make sense? 18 feet? 18 and a half feet? Yeah. Yeah, I'd go with that.